Welcome to eachCoulomb Academy YouTube channel. In this session, I am going to discuss Cbse class 10 electricity question and answers chapter 11. If you like this video, please like, share and subscribe to our channel. Please share your valuable comments in the comment section. Okay, let us go to the today's topic. First one, part 1. NCERT questions. In NCERT questions, first one, what does an electric circuit mean? Here in this question, what is the meaning of electric circuit? A continuous and closed path of an electric current is called an electric circuit. Here electric circuit nothing but electrons are flowing in a complete in closed path. So a continuous and closed path of an electric current is called an electric circuit. Motion of electrons is known as electric current, and this electric current is passing through the entire in a closed path without any breaks or without any open circuit or without any open switches, then it is called as electric circuit. So a continuous and closed path of an electric current is called an electric circuit. Next one, define the unit of current. Here electric current is motion of electrons. Now what is the unit of current? The unit of current is ampere. 1 ampere is the current flowing through a circuit when a charge of 1 coulomb flows through it in 1 second. Here electric current is denoted by letter I. I is equals to Q by T. Q nothing but charge and T nothing but time. So 1 ampere is the current flowing through a circuit when a charge of 1 coulomb. So here the unit of charge is coulomb and the unit of time is second. So 1 coulomb by 1 second gives 1 ampere. The unit of current is ampere. So 1 ampere is equals to 1 coulomb by 1 second. So the unit of current is ampere. Then 1 ampere is the current flowing through the circuit when a charge of 1 coulomb flows in 1 second. It is known as 1 ampere. Compulsory it should be coulomb, 1 coulomb and 1 second. Ratio of Q by T, that is Q by T, is known as electric current. The relation between I, Q and T is I is equals to Q by T. Q is the electric charge and T is the time taken, and where I is the electric current. So the unit of current is ampere. 1 ampere is equals to 1 coulomb by 1 second. See nothing but here coulomb. The unit of charge is coulomb. So 1 ampere is equals to 1 coulomb by 1 second. So 1 ampere is the current flowing through a circuit when a charge of 1 coulomb flows through it in 1 second. Okay, next one. Calculate the number of electrons constituting 1 coulomb of charge. Here now we are calculating the number of electrons. Total charge Q is equals to N into E, where E is the charge of an electron, which is equals to 1.6 into 10 to the power of minus 19 coulombs. This is the charge of electron. 1 coulomb is equals to N into 1.6 into 10 to the power of minus 19. So N is equals to number of electrons. N is equals to 1 by 1.6 into 10 to the power of minus 19. That is equals to 6.25 into 10 to the power of 18. This is the number of electrons. So N is equals to 6.25 into 10 to the power of 18. These many number of electrons constituting in 1 coulomb of charge. Okay, next one. Name a device that helps to maintain a potential difference across a conductor. Here, which instrument is used to measure potential difference across a conductor? That is, the device name is a cell or a battery. cell constituting two terminals. One is a positive terminal, another is a negative terminal, and the battery is the connecting of all three or two or more cells in a series is known as battery. So which device is helping for us potential difference across a conductor? Cell or a battery. With the help of a cell or battery, we are maintaining a potential difference across a conductor. Okay, next. What is meant by saying that potential difference between 2 points is 1 volt? Here the unit of potential difference is 1 volt. It means that 1 joule work is done in moving 1 coulomb of positive charge from one point to the other in an electric field. Here potential difference V is equals to, the potential difference is V, that is, or we can written as voltage. So V is equals to W by Q. W nothing but work done, Q nothing but charge. So here potential difference is measured in volts. So by using voltmeter. So 1 volt is equals to 1 volt is equals to work done units 1 joule by charge units coulombs. So 1 volt is equals to 1 joule by 1 coulomb. So when we are telling that potential difference between 2 points is 1 volt, when 1 joule of work is done in moving 1 coulomb of positive charge from one point to the other in an electric field is known as 1 volt. Okay, 1 volt is equals to 1 joule by 1 coulomb. Next, how much energy is given to each coulomb of charge passing through a 6 volts battery? Here we are calculating the energy given to each coulomb of charge. They given that potential difference is equals to 6 volts, charge Q is equals to 1 coulomb. So energy is equals to Q into V into 6. So complete here they given as V nothing but here Q1 into voltage 6. So this is equals to 6. 6 into 1, that is equals to 6 joules. So Q into V is equals to 1 into 6, that is equals to 6 joules. So 6 joules of energy is giving to each coulomb of charge passing through 6 volts battery. Okay, next. On what factors does the resistance of a conductor depends on? Here resistance of a conductor depends on its material, that is nature of the material, and length of a conductor and area of cross section. So here resistance of the conductor depends on first nature of the material, and next length, and next area of cross section. Resistance is directly proportional to L and resistance is inversely proportional to area of cross section. So resistance of a conductor, on what factor resistance of a conductor depends? Resistance of a conductor depends on its nature of the material, length and its area of cross section. Three factors, one is the nature of material, one is the length, the other is the area of cross section. Okay, next. Let the resistance of an electrical component remains constant while the potential difference across the two ends of the component decreases to half of its former value. What change will occur in the current through it? Now here in this according to Ohm's law, V is directly proportional to I. Potential difference across between a two conductor across a conductor is directly proportional to the current. So V is directly proportional to I. Since potential difference V decreases to half, here potential difference is decreasing. V by 2 is proportional to here I by E. So hence the current flowing through the component will become half. So here when the potential difference decreases, automatically current is also decreases. Same. Why? Because these two are directly proportional. If potential difference increases, electric current also increases. If potential difference decreases, electric current also decreases. Here in this one, potential difference is decreasing to half, that is reduced to half. So similarly, automatically current flowing through the component will become half. It is also reducing. Next, why are coils of electric toasters and electric irons made of an alloy rather than a pure metal? So this is because of the high resistivity and high melting point of the alloy. So here why we are not using these coils for the by using pure metal. Now why are coils of electric toasters and electric irons made of an alloy rather than a pure metal? Yeah, why? Because an alloy has a high resistivity because and high melting point of the alloy. Also they do not oxidize when red hot. So that's why we are using preparation made of an alloy. These electric toasters and electric irons are preparing by using an alloy. Why? Because this is because of the high resistivity and high melting point of the alloy, and also they do not oxidize when red hot. Next one, draw a schematic diagram of a circuit consisting of a battery of 3 cells of 2 volts each and a 5 ohm resistor and an 8 ohm resistor and a 12 ohm resistor and a plug key all connected in series. Now we have to draw the diagram. See the schematic diagram of circuit. This is the schematic diagram of the circuit. They are using 3 cells of each cell having 2 volts. In these are connected in series, and then positive terminal of the connected to 5 ohm resistor. One is a 5 ohm resistor, another is a 8 ohm resistor, and there is a 12 ohm resistor. So all should connect in series. And the next this connected to plug key and all connected in series. This is the schematic diagram of the 2 volts 3 cells and resistors 3 resistors. One is a 5 ohms, 8 ohms and 12 ohms. These are connected to plug key. Okay, with using connecting wires. Next question. Will current flow more easily through a thick wire of or a thin wire of the same material when connected to the same source Y? Here the current will flow more easily through a wire which have comparatively less resistance according to the relation R is inversely proportional to A. A nothing but area of cross section. The thin wire has less resistance, so current will flow more easily through a thin wire. Here R is inversely proportional to area of cross section. If resistance increases, area will decrease. If suppose area is increasing and automatically resistance will decrease. So here the current will flow more easily through a wire which have comparatively less resistance. If resistance is less, area will be here A nothing but area of cross section. Area will be more. So current will flow more easily through a wire. So according to this relation, the thin wire has less resistance. So the current will flow more easily through thin wire. Okay. Thanks for watching this video.